to be as efficient as possible. So you may look at this and say, all right, let me simplify each thing. But I kind of look at it more like, why not chuck them all into a calculator and see which one's the biggest and which one's the least. All right. So if we're using the Desmos calculator, that's pretty not bad. We could also use a TI calculator. I'll show you that as we go. All right. Let me just get a fresh new Desmos here. All right. So when you're and actually let me just take you through that process real quick. When you're creating a Desmos account, it's very simple. You just go to desmos.com. So if you haven't already done this, you're going to want to do this at some point in the not too distant future, because Desmos allows you to save your calculators. So for the purposes of this class, that's really beneficial, because if you think about, okay, well, I made this graph, it took a few minutes, and odds are on the test there's going to be a similar type question, then why not have that calculator accessible so that you can just tweak the calculator that you've already created rather than making a new one from scratch? It'll save some time. Also, it's a nice, efficient way to submit work. So I mentioned this on Thursday, but it's already almost a week ago. But when it comes to taking tests, we're going to be looking to do multiple choice questions digitally, but the free response, the show all work questions, we'll do that with pencil paper, right? That being said, sometimes you want to show some work with your multiple choice questions. This might be the way to do it, all right? So if you haven't created a Desmos account, it'll be mandatory at some point, but at this point you can opt to do it. You just go to desmos.com, and then there's a sign-in login option. Actually, let me open a different browser so I can show you. We'll do a incognito. No, I don't want that. So if you go to desmos.com, you'll see login or sign up. Just go to sign up. Now you have an option of creating an account as a, just identifying a username, password, that kind of thing. But you could also sign up with Google or Apple. All right. So if you have Apple ID or Google ID, Google screen name, Google account, some capacity, you could sign up with that. If you don't have a Google account, then you're not going to do that. But if you do, I recommend doing it that way, because odds are you're going to hang on to your Google stuff for a while, like for the rest of your life. All right. Apple, it all depends. If you have an Apple device, if you have a phone, an Apple, a personal device, then you can use your personal information, but you could also use school information, because you do have MacBooks. All right. So sign up with whatever account, and then you just put in your credentials. All right. So take some time and do that, and you'll see. It'll be for your own benefit. If you don't do it, then you won't be able to save your work. You'll realize pretty quickly. All right, but once you're signed in, you go to Graphing Calculator. All right. And then you have a fresh new graphing calculator to work with. And once you tap into a field, the actual calculator presents itself. All right. So looking at example, or the do now number 1, 3.5, that's in decimal form already, but 10 divided by 3, oops, it'll convert it over into decimal form for you, so you're good to go there. All right, so we now know that 10 over 3 is less than 3.5. All right, but the radical 14, what about that one? You type in radical 14, that's the biggest. All right, so in order, it should be 10 thirds, 3.5, radical 14. All right, you don't want to put the decimal values down. on paper because that's not what they asked. They said order the numbers, the ones that you see here from least to greatest. All right, but now you see you have a little record of your work. All right, so if you want to, let's say that this was a test, you could hit that little plus sign and tap in note and say that this is, hit the little keyboard there, number 1. If I could find the pound symbol. All right, and then you're like, okay, well that's not where I want it to be. Just drag on the side, that little box on the left-hand side, click and drag that to the top, and now you have it labeled. All right, and you're like, okay, well why would that be useful? Because if you have an account, you could hit this little share icon, it'll create a share link, and on a test you could submit that, just copy the link, submit that as part of your work. All right, so flashing forward to a test, and by the way, we're nowhere near a test. So I must have said test like 15 times already in class. So, nothing strikes fear into the heart of students quite like a math test. Right? Some of us are a little bit better at managing those, but it doesn't mean that it's going to be a comfortable experience. But when we do take a test, let's say it's 10 multiple choice questions, there will be an 11th question that doesn't count for any credit. It's just a field for you to submit a share link to your Desmos work or to upload a file of handwritten notes. All right, so this is supposed to be a gift for you. I'm not going to go the route of saying, "Oh, you're welcome for this magical gift," because you don't know what it's all about yet. But trust me when I say that it's something that's good for you. All right, it's not an unnecessary extra step. It's a step that hopefully you'll appreciate. All right, but down the line I'll ask you again if I'm right, and you'll let me know. All right, so I want number 2, so I can hit that little duplicate icon, and if I want, I can duplicate some of my work. Like for example, that 10/3, I hit that little double page thing, and then hit done. Why did I do that? Well, I see in the first number in the second problem has a 1/3 in it. That's not too dissimilar from 10/3 in terms of appearance. So then tap on it, hit the back arrow, and just get rid of the 0. All right? You can type it in again. I mean, in the grand scheme of things, typing in 10/3 versus 1/3 it shouldn't be difficult. But think about some really lengthy thing that you just typed in, and you have to type it in again just to change one little aspect of it, maybe a minus to a plus. That's a nifty feature. All right. So then you look at it and say, well, that's not in the right place. Drag it down, and then put in a number 2. Oops. It's funny because before I had a keypad, but now I don't. Like a floating one. I'll have to figure out why that's the case. But I'll just write number, I know why. Like a schlemiel. I didn't put the note, right? So if you're going to type it, I'll actually show you my mistake. All right, so let's say you wanted to type in something, but you didn't select note or open quotes. And I type in NUM. It tries to create sliders for each one of those numbers because it thinks that each one of those letters is a number. All right, so it's actually thinking that I'm typing in variables. All right, so just make sure that you hit that little plus sign with the note key, and then your iPad or your computer keyboard will appear, and you'll have the option to type in the pound like I did before, wherever it is, and a 2. All right. So then 0.16, we don't need that in decimal form. It already is. The radical 1/4, maybe you don't need that in decimal form because you look at that and say, well, a square root of a quarter, if you're taking the square root of a quarter, you're taking the square root of the top and the bottom separately. Square root of 1 is 1, square root of 4 is 2. So that's 1/2 or 0.5. All right, but if you don't know, just type it in. Now, just as a general rule of thumb, if it's singular numerical monomials, single values, you could just type in the division as you go. So if I do 1 divided by 4, it'll come up that way. But as a general rule of thumb, we want to get in the habit of hitting the division key first, because we're going to be putting algebraic expressions in there. When you put in an algebraic expression, it's not just 1 over 4. It's usually x squared plus x plus something else. It gets a little lengthy. Desmos has a harder time if you try to do the division after you type in a string of an expression. It'll think you only want to divide the last term. All right. Whereas if you put the fraction bar in first, then you just tap into the numerator, type in a 1, tap in the denominator, type in the 4. All right. Now you see on the left-hand side, you see that little fraction icon there? That's telling us that a fractional answer is available if you tap on the icon. All right. So you tap on it, it'll convert your decimal to a fraction. All right. It's pretty nifty, especially if you think back, all those questions in previous years of simplify the fraction. Desmos is going to do that for you. The TI calculators will do that for you too, but obviously it's not going to be just a matter of tapping your screen. I'll walk you through all that stuff in a little while. All right, so we know that the 0.16 is the smallest. The 1/3 is next in line, and then the radical 1/4. All right. So I'm not going over this to show you how to order numbers. I'm going over this to show you how to type stuff into Desmos. All right. So if you're like, wow, he's spending an awful lot of time on something that's actually pretty easy, why are we bothering with this? That it's to show you the technology. Not. I mean, I have faith that you can look at decimal values and say which one's bigger. All right. So the last one is very similar to the previous one, so what I wanted to do is switch over to the TI calculator. All right, now, if memory serves, my TI calculator stopped working on the computer, so I'll have to go with my my funky app emulator, but we'll see. I'll have to put in a service request because this shouldn't take this long. It should pop open. Oh, look at that. It worked. Shocking. So this is what the TI Silver Edition Plus fancy calculator looks like. There's different variations. I'll hit the drop down. You got the TI 84 Plus CE, the TI 84 Plus C, and then the TI 84 Plus. The C just stands for color. All right. So if you get a TI calculator, and before the end of the year you'll need one because of the Regents exam. So that's going to be a thing. Now in the last couple of years, the Regents was either not available or optional. All right. I don't expect that to be the case this year. The reason why it was optional was because we didn't have everybody in school across the state, right? Because it's a state exam. Like, just because we were all in school at the end of the year in this district doesn't mean that in Utica they were all in school, So they had to account for that. But this year, I fully expect there to be an in-person pencil paper Regents exam. I don't like the idea. I thought it was great when we didn't have to have a Regents exam, but we have to operate under the assumption that we're going to have one. All right. And so if that is the case, you will need one of these calculators. I have a supply. I mentioned this last week, but I mentioned a lot of things last week. I have a supply of 12 to 15 of them, depending on whether people actually return them. So I can loan out some, but the more of you that actually have the calculator, the better off things are going to be. All right. So if you don't have one, I would like you to see about getting one. All right. Anyway, so if you wanted to do a problem like this on the TI calculator, it's not as user friendly, but again, it's what's allowed on the state exam, so we learn it. All right. So that alpha key, first off, if you've never seen a TI calculator, you turn it on by hitting the on key. I mean, I think that part is obvious. But you turn it off by hitting second on. All right. the reason I bring this up is because I think I mentioned in this class last week that with my old school TI-84, this jammy here, no color screen, no bells and whistles, all right? With this one, I haven't had to change batteries yet, and I've had it for years, all right? But people will find when they get TI calculators for the first time, they've never used them before, they're like, what is this he's talking about? The battery doesn't die. Mine died in like 2 days. It's probably because you're not turning it off, all right? It has an auto shut off. It'll turn off after a couple of seconds of not being used, like 30 seconds, something like that. But that's 30 seconds of wasted energy. So you'll find that you have to change your batteries a lot quicker. Now, unfortunately, what tends to happen is people find out they need to change their batteries on the day of the Regents exam when they sit down to take the exam. Then they panic and they hope that we have spare calculators, and we usually do, but it's dangerous territory. Right? So make sure you hit second on to turn your calculator off. Mine won't turn off because it's an emulator. All right. So it's not actually a calculator, it's a program designed to pretend to be a calculator. So if I'm in my home screen, so blinking cursor in the upper left-hand corner, if I want to put a fraction in here, what I can do is hit alpha and then the y equals key, and you'll see an option n over d. Now, if you're anything like me, not to say that that's a good or a bad thing, you're already not liking this. Because the other one was so easy. All you had to do is put a little divisions, boom, I got my fraction. Common sense. This one, you got to go looking for it. So alpha, y equals, you see n over d, numerator over denominator. All right. You also see some other options like convert fraction to decimal, which I never understood the need for. Like, I know how to convert a fraction to a decimal. You divide the top by the bottom. That's it. Why do I need a function in a calculator to do that? But they built it in. What I will say is, odds are, if you're looking for something funky in the calculator, it's probably alpha top row. All right. So if you hit alpha and then window, alpha and then zoom, alpha then trace, and then the last one doesn't have an alpha, but alpha y equals brings up your fraction stuff. Alpha window brings up, you have absolute value, you have some other more complicated things that we'll get to. Then this involves matrices, which we'll also get to, and then some variable shortcut keys. All right, so useful stuff, but only if you know where to look. All right, so alpha y equals option 1, then we type in this case it was 21 over 3, so 21, hit the down arrow to put it as a fraction, and it'll convert it over for you. All right, and when I say convert, I mean put it in simplest form. All right, if you want a decimal version of 21 over 3, all you have to do is 21 divided by 3, and it'll spit out the decimal answer for you. In this case, 21 divided by 3 is simple. It's just a 7, but that's the process. So, like, for example, we have the 0.6, but then we have the radical 9 over 16. So let's say I want to put in a radical. So I'd hit second. Right above that x squared key is the little radical symbol. So I'd select that. Then I would type in alpha, y equals to bring up n over d. Then I would type in the 9, down arrow 16, and it'll convert it over for us. All right. And again, converting it is just my way of saying it's going to put it in a more convenient form. All right. So we know that this is 7. 0.6 is 0.6, but you can put that in fraction form if you want. And this is 3/4. All right. Most people don't need a calculator to say that 3/4 is 0.75. But if you do, you have one. And that's not to make anybody feel bad. It's just that, there's some things that I would like to think are common sense. So if you had 3 physical quarters, how much money do you have? 0.75, 75 cents, right? So if you had 7 quarters, okay, maybe you have to do a little thinking, but you know that it's increments of 25 cents, 0.25s, you'd say, okay, well, 4 of them make $1, then I'd have an extra 3 of them, so $1.75, 1.75. All right, so yeah, I mean, it's just a little glimpse into how my brain works, but most of the time it's me trying to relate the math to something physical. All right, it makes sense for me. If it makes sense for you, then that's good. All right. So in order of least to greatest, we have the 0.6. We have the 0.75, otherwise known as the square root of 9/16. And then we have well, I'd have to write it as 21/3, but that's the 7. All right. So I know, and it's very tedious. That's just adult way of saying incredibly boring. But I wanted to show you the calculator stuff. All right. Because I have answer keys are online. You've already seen them, hopefully. All right. The link that you saw for the actual file, right below that is the link for the answer key to that file, the whole thing. All right, so you have the answers. It's the explanation that should be helpful. By the way, you may have noticed this right in the beginning. I started a screen record. This goes up on the internet so that you have access to it later, because I know not everybody has TI calculators. And honestly, it might be the case that you don't even get a TI calculator until like April. I'll leave that up to you. All right, because it's probably a good strategy to say, all right, let me take a wait and see approach on this. Maybe they won't do the Regents exam. If I had to bet real money on it, I would bet that they would be having the Regents exam rather than not having it. But if you want to take that chance and go with Desmos calculator the whole year long, and just at the end say, okay, let me get into this TI business, the one thing that you don't want to experience is you open the TI calculator, you turn it on. Oh, I remember that from the first math lesson of the year. But then you think to yourself, okay, but I don't know how to do anything else. So what do? You raise your hand in class. Can you teach us how to use the TI calculator? And I'll be like, what, the whole thing? Like every aspect? Oh, that's going to take a while. The videos should help. All right, so you could always go back in time and take a look at the videos that I record and put online. All right, so hopefully you had an opportunity to read through the real number system. That little graphic there should be pretty helpful. The rational numbers part, it's usually pretty straightforward if you think of it in the sense that it's any type of number that you can think of, not involving a radical. All right, but then you'd say, well, what about like radical 9? Well, radical 9 never really had to be a radical, because that's the same as saying 3. It's kind of like disguising a number for the sake of disguising a number, right? So why would you ever write a radical 9 instead of 3? Well, the short answer is you wouldn't do it on purpose. It would just work out that way as you're solving a problem. You go through the solution, you get to like step 17, and you're simplifying, you see a radical 9, you're like, oh, okay, I'll just write a 3 instead. All right? So recognizing that as a rational number is useful, and you'll see why as we go forward. All right? But the root of rational is ratio, which is another word for fraction. All right? So anything that could be written as a fraction is going to be considered a rational number. All right? So if you look at, for example, radical 7, a nice nifty Desmos way of figuring out whether a number is rational or not, you see right next to it in blue, it didn't present us with a fraction icon. That's saying Desmos does not have a fractional equivalent for this number. Whereas if I put in, let's say, the square root of 7 over 21. Bad example. 7 over 63. I accidentally put in something that was irrational. All right, 7 over 63 would simplify. You look at it and say, well, the square root of 7 doesn't simplify. Yeah, but 7 goes into 63 9 times. So you get 1 over 9, which simplifies down to 1/3. All right, maybe you didn't recognize that. That little fraction icon there is going to help you, because if it can be represented as a fraction, it's a rational number. All right, so you think about what other types of numbers could also be represented as fractions. Integers. All right, so like negative 10 or positive 2. I could write negative 10 as a fraction. Negative 20 over 2. All right, done. It's a fraction. It could be represented as a fraction. All right, if I said a 2, that could be 4 over 2. 4 over 2 is 2. 4 divided by 2 is 2. All right. Whole numbers is just a subset of integers. So take the whole set of integers going from negative infinity to infinity and ditch all the negatives. Now you have the set of whole numbers. All right. Ditch the 0 from that set. Now you have the set of natural numbers or counting numbers. All right. Now the whole set of numbers together, including all those funky radicals, that makes a set of real numbers. So you'd start asking yourself, well, what makes something not real? Right? Not real would be imaginary. So, for example, the square root of negative 5. It'll say undefined on Desmos. That's because it doesn't have a real numerical value. Because at the heart of Desmos, it really is a graphing calculator. The graphing calculator is limited to the real number system. It's not going to graph what we call complex numbers, numbers that have negatives under radicals. It's not going to do that. But it'll say it doesn't work. But it does work, just not in this universe. All right, we're living in the real number system. If we went into the complex plane, the imaginary universe, the astral plane, if you will, then you're looking at imaginary numbers actually taking shape and having meaning. All right. So on the TI, if I typed in the square root of negative 5, it's worth pointing out, and this isn't like a TI bashing kind of exercise here. It's more like, let me just take the time to point out the differences between the two. So on the TI, there's a negative key and there's a minus key. We're all going to make mistakes in putting a minus when we should put a negative and put a negative where we should put a minus. All right. So if I put a minus here, it says error syntax. All right. Very important on the TI calculator. If you get a syntax error, syntax is just it's the rules of language. All right. So in the English language or any kind of language, we call that grammar. All right. Grammar, spelling, things like that. All right. For the TI calculator, it's the same idea. The minus means one thing, the negative means something else. All right. So let me quit here. If I type in the square root of negative 5, it says error non-real answer. In both cases, you get an error. But one of them is because you did something wrong, and the other is because it's not a real number. Right? And it flat out tells you it's not a real answer, non-real answer, imaginary. All right. Now, if you ever get a syntax error, so let's say I type in, I'll keep it simple. Instead of putting in a negative 2, I accidentally put a minus 2. It'll bring up an answer in front of it because it thinks you want to subtract from the thing that came before it. All right. So you have that little advantage. But going back to this one, just hit the up arrow to get to the previous computation. If I hit enter on that, or if I hit enter on anything and I'm presented with a syntax error, just hit go to. All right, select option 2, go to. It'll bring you to the scene of the crime. It's telling you here that there's something wrong with that minus sign. Now, it's on you to figure out what's wrong with it, but it's saying this is the problem right here. If you fix this, you're good. Sometimes, though, you'll see things like that. You get the syntax error. You'll look at it and you say, I don't see anything wrong with this. The 2, the minus 3, the fact that it's elevated is supposed to make it a little bit more obvious that it's negative, but it will bring you to the scene of the crime. So if it's a minus sign, and you get a syntax error, make it a negative. If it's a negative and you get a syntax error, make it a minus sign. All right. So little tricks of the trade to help you along the way. But, in terms of rational and irrational numbers, you could just type it into your calculator and see what comes up. That's one of the benefits and drawbacks of being able to use a TI calculator, because you look at this, or any kind of calculator, because you kind of look at it and say, well, I don't really need to know this because I could just type it in. But we got to be careful, because on the exam and on the tests that I give you, the questions are going to say things like, explain why. Right? Why is this number irrational? It might even say, radical 2 is irrational. Explain why, using proper vocabulary and terminology from the unit. All right, so you don't want to just rely on the calculator. But if it's a true-false like this, I'm just going to wipe out all this stuff.
You could just do the equation, like radical 2, and it's asking if it's irrational, true or false, and you would see, oh, well, it obviously is. It continues on.
You got it. All right, so boom, shakalaka. In Desmos, you take a look and you don't see a fraction icon next to it, it's irrational. All right, so true. All right, repeating decimals can be represented as fractions. All right, so you don't have to type that in. All right, if it can be expressed as a fraction, it would make it rational, so this one would be false. Pi is always irrational. If you're not sure, again, same deal. Type it in. You're not presented with a fractional equivalent. All right, that fraction icon isn't there. So pi is irrational, true statement. Radical 144 is irrational. Well, radical 144, square root of 144 is 12. If you don't know that, type it in. That is not a radical anymore. We got rid of the radicals, so this is going to be false because it's not irrational. All right, the square root of 3 squared. Well, square root of anything and a power of 2 will cancel each other out because they're opposite operations. If you're not sure, type it in, but that's going to be a rational number, so this is going to be false. Number 6 has a pi in it. Right? It's got other stuff, but it's got the pi in it, so that's going to be irrational, so that's going to be true. The only way that would be false would be if maybe there was a pi on the bottom of the fraction also where they just canceled out, but that's not what happened here. Integers are rational. True. Integers can be all integers can be represented as fractions. 0 is irrational. 0 is in a set of real numbers, real rational numbers. All right? You could represent 0 as infinitely many fractions. 0 over anything except for 0. And you get a fraction that's equivalent to 0. So that's false. All rational numbers are integers. Well, no. I'll give you a quick counterexample. We call them counterexamples when you find that one case that doesn't work. The counterexample here is, or one of many, is like 1/2. 1/2 is a rational number, but it's not an integer, so this is going to be false. All decimals are rational. Well, no, you got plenty of examples right here. These are some decimals, and they can't be converted to fractions. All right, so that's got to be false as well. All right. So the next bunch of pages, now I mentioned this, or I left it with the subplans. It was for you to tackle these problems from pages 2 to 5, but you didn't have the benefit of the instruction. All right, so tonight's homework is to just revisit that assignment. All right, I'm going to keep it simple. I didn't want to leave you to your own devices and start the year off on a bad note. If you had trouble with the assignment over the weekend, then you have another crack at it. If you didn't have any trouble, then you got a free night. All right, so good for you. All right, so I'm going to stop the recording.
To do one